Thank you for this great event that the whole Frontline Genomics team has put on to bring us all together. So next generation sequencing has become pervasive over the last few years. And biologists are primary consumers of NGS data analysis results. And yet, most NGS data analysis tools are designed around bioinformaticians. Why? Well, it's because it's difficult. It's tough to design for biologists. Biologists, by and large, are certainly very knowledgeable about science, but by and large are not quite as adept at, utilizing computational tools, right? And so, as Will said, I'm Tom Kent. I'm president of Mavericks Bionics, and I was asked to talk about how the important factors for designing NGS data analysis tools for the biologists. So let's begin with what is Mavericks and why do we care about this topic? What is the mission of Mavericks? Well, if you look at biologists, they are very focused on producing their results, and they know that there are tools and techniques that can enable them to advance their innovations. But they're effectively being caged because a lot of these tools and techniques are not available to them in the ways that they need them. So in essence, our focus is to free the biologists, to enable them with tools and techniques that can really be used in the way that they need them to be used and to really accelerate their advancements in science. And really, who and what is Mavericks Bionics? Well, we're a company that is really based around bioinformatics expertise with a strong biology background. And we're focused on enabling biologists to leverage the benefits of NGS, of next generation sequencing. With software engineering expertise, we have built a cloud-based NGS data analysis platform that provides multiple data analysis kits or pipelines, and we support a number of different organisms. And utilizing the cloud, we're able to take advantage of the extensive scalability, the broad accessibility, and we enable collaborations. And when it comes down to it, what we're really focused on is to make complex genomic and transcriptomic analyses simple for the biologist. Now, we've focused on NGS. Why NGS? Well, because NGS really has emerged as an area tool that can support a breadth of applications. Right now it's being used very heavily in diagnostics, in drug discovery, genetic screening, personalized medicine. Daniel was just talking about the longitudinal study and their WGS omics activities. George Weinstock earlier was talking about microbiome studies. It can be applied to that. And Manolis Kellis was talking about his studies going from genomics to medicine. So it can be applied to a wide range of applications. And NGS provides much greater resolution and precision than previous techniques. We can get down to looking at single bases, whether they are commonly found or rarely found within a species. It's very robust. You can use it for a number of different activities. For example, we can look at common gene expression. We can look at rare gene expression. And we can use the same NGS data for many different purposes over time. And they can be studies that are focused on a single point in time or time course studies like the longitudinal study that Daniel spoke of. Now, when we look at the tools, what are the important factors, what are the critical factors for designing for a biologist? Well, if I'm a biologist, there are really four critical factors. Number one is ease of use. Give me a tool that makes it easy, that's something I can understand. And don't make me learn about all the different individual bioinformatics tools and to validate those tools. And certainly don't make me stitch those together in a pipeline to make it all work together. Just give me something that works for me. Secondly, make sure that it is scientifically sound, that it's been validated. Because if I can't be confident that the results that I'm going to get are accurate, then it's just not worth it for me. And in fact, it can be counterproductive. Third, open and reproducible science. I would like open data analysis tools that I know have gone through, that have been subjected to peer review. and I want to be able to reproduce my experiments. If I can't reproduce experiments, then it's as if they didn't happen in the first place. And last, easy accessibility. All of the other three areas are incredibly critical, but if it's not easy for me to access and I can't get to it when I need it, then the other factors don't really even matter. So let's talk just a moment about ease of use, and I'll provide an example of how we've really worked hard to build in ease of use into our platform, because quite frankly, creating something that's easy is difficult. And so here's an example of what a scientist, what a biologist would need to do to launch an analysis for one of our pipelines. And we've really boiled it down to 3 easy steps. Start off by naming the analysis, and it can be any name that the biologist chooses. Secondly, identify and specify the samples that are going to be used in the analysis, and that can be a small number of samples or a large number of samples. And we provide a mechanism for building a manifest, a simple manifest if it's a large number of samples. And then set a few configuration details. Tell us what sequencer was used, what reference genome you want to compare against, a couple of other parameters, and then you're ready to launch the analysis. And it really is that simple: 1, 2, 3, and launch. And so you can imagine taking these 3 steps that you see. Behind the scenes, there could be dozens or even hundreds of steps that would need to be performed that we do automatically for the biologist. Now, moving to the scientific soundness, one of the first steps is dealing with data quality, making sure that the quality that is going to be analyzed is of high quality. And we have a number of different tools in this space here. We have a tool that can look at the reliability and the quality of the individual bases. And we can look at that before the trimming is done for the analysis and after the trimming is done. And here's an example of, in the green, that's a very high quality. Yellow is getting into the warning zone, and red is bad quality. Post-trimming, we see that the quality has really risen considerably. We have another chart here, the gene body coverage chart, that shows the number of reads, the abundance of reads that took place within the genes. We also have read counts and other charts. The read count will show you the total reads for a sample, the number of retained reads, and the number of unique reads that were found with your sequences. If I'm a biologist, I need access to the data sets that were generated for the analysis. So give me easy and free access to any and all of that data that I may need. Secondly, you're going to provide me with some fundamental data sets, but don't just give me the BAM files, the VCFs, the DE files, the BED files, and so on. Give me some level of visualization so I can interpret, at least to some extent, what I'm seeing there, and combine it with a genome browser so I can compare that against my reference genome. Publication-ready images. I may be ready to publish to a journal. I may want to just share this information internally with my colleagues, so give me some publication-ready images that I can use to aid in my communications. Talking about open and reproducible science, there are multiple aspects there that are important. First of all, we talked about open tools that have been peer-reviewed. And as a biologist, I want to know the pipeline details. I need to know that if I'm going to publish or share with my colleagues. I need to have consistent results. If I'm going to run an experiment once or multiple times, I need to get results that are consistent and repeatable. And pipeline versioning. As a biologist, I don't really think a lot about the versioning details, but I do know that I want pipelines to continue to evolve and improve. However, if I need to come back and rerun an experiment on that same pipeline, I want to know that I can do that a week later, a month later, a year later, and I can get the same version of that pipeline and reproduce my results or run a new set of samples under the same pipeline. So that'll satisfy those requirements there. So how are biologists reacting to the tools that we've provided? Well, these are just a few quotes that we've received that show that it's working. We're providing the kind of ease of use and capabilities that the biologists are needing. And these quotes talk about the ease of use, the intuitiveness, and the scientific soundness of what we're providing. So I think we're on the right track there. And so to summarize, the key factors for designing NGS data analysis tools for biologists needs to provide all of these 4 key factors: ease of use, scientific soundness and validation, open and reproducible science, and easy access. And with that, if you'd like to come over to our booth, we're just right over in booth 44, and we have Wendy and Mark and myself over there if you'd like to come over and learn more about how Mavericks really makes complex genomic and transcriptomic analyses easy for biologists. Again, feel free to stop by. So thank you for your time.